So guys, this is question number 5 of JEE Advanced 2026 paper 1. So in this question they have asked very standard question but in a entirely different way. They are saying that electron is jumping from nth orbit to first orbit and they want to calculate change in kinetic energy. But they are giving kinetic energy in an entirely different way, which is Vn by Rn, which is velocity divided by radius, right? So we need to think of some creative way. So first of all, kinetic energy we know is nothing but half mv square. And but second postulate is given by mvr is equal to nh upon 2 pi, right? So I can say this is half m v multiplied by v, and half mv I can pull it from here, it is nh upon 4 pi r into v. So from here I am getting h upon 4 pi into v by r, correct? So if I think this, if I apply this formula, I will get kinetic energy, change in kinetic energy. I can take h upon 4 pi will be common beta, and I am putting mod anyway, so I can do initial minus final, final minus initial, it doesn't matter. And I like there is a mistake here, this is a n term also here, this n term, right? So nh upon v. So fill this value, I'll get n vn divided by rn minus v1 divided by r1, and n value is 1 again. So that is option number A, correct? Now in option number B, they are again asking change in de Broglie wavelength, but this time they want us to use E square by 4 epsilon naught. So but kinetic energy and E square by 4 epsilon naught comes in the potential energy. So remember the potential energy formula was minus E square upon 4 pi epsilon naught r, correct? And if you remember that in Bohr's model we know that total energy was negative and total energy magnitude was equal to kinetic energy magnitude, or this was equal to, the kinetic energy magnitude was actually half of potential energy. Why half of potential energy? Because total energy was actually negative. So if I use this logic here, I can say that potential energy magnitude divided by 2, which is E square upon 8 pi epsilon naught r, will be nothing but kinetic energy, which is, let's call K, right? From here I am interested in calculating 2 pi r. So if I calculate 2 pi r beta, I will get E square upon 4 epsilon naught. 4 epsilon naught has like 4, not 4 pi, because pi I have used here. So I will get 4 epsilon naught k. From this, if you focus, you can get this, right? And this is equal to n lambda. Beta n is a principal quantum number and lambda is our de Broglie wavelength. So from here, lambda is coming out to be E square upon 4 epsilon naught n into k. But from here, if I think that lambda n minus lambda 1 mod, if I calculate, I'll get E square upon 4 epsilon naught common, and in the mod I will get n times kinetic energy of the nth orbit minus 1 time kinetic energy of the first orbit. So if you see in the first orbit, now there is a missing n here. So I'll say B option is wrong while A option was correct. Okay, let's similarly move to the next option, which is C. C option, they want radiation emitted, and again epsilon naught upon 8 pi epsilon naught. Beta, we have already talked about that total energy is equal to amount of kinetic energy. And mod of kinetic energy, we can see mod of kinetic energy we are getting from here, right? So we can say total change in kinetic energy is equal to change in kinetic energy, and that will be equal to mod, actually I have to put here and here also. So I can see that A square upon 8 pi epsilon naught will come common, and I will get 1 by r1 minus 1 by rn, and but mod I will put again here, and this is equal to h nu, right? So I have to send h here. So from that, 3 option will match. Finally, we need to find out change in total energy of the electron. So again, change in total energy of the electron is nothing but change in kinetic energy. So change in kinetic energy we just now calculated in the option A, right? So change in the kinetic energy of the electron was h upon 4 pi nvn by rn minus v1 by this. So beta, we can say there is a factor of 2 missing here, because total energy magnitude is equal to kinetic energy magnitude. The option A and option D cannot be correct simultaneously. Therefore option D is actually wrong.